So in this video, we'll learn about gradient descent. Now the gradient descent is basically a part of machine learning. Now the machine learning is generally used for predicting something, like predicting the farm output given the area of the farmland, or predicting the price of real estate property given its area. Similarly, it can predict other things also, like predicting whether an email is spam or not. So the machine learning depends basically on two things. First is model, which is actually used for predicting something. It is the tool that predicts. Second is data. Now the model learns to predict using the data. For example, there are many models like linear regression, random forest. They use data. For example, in order to predict the price of a house, you need data like number of bedrooms that house has, or the area of the house, and how much those houses actually cost. This is the data. Now, model and data are not enough to predict something. You need to train the model in order to make it worthy of predicting. The model needs to be trained on data. You can compare this to an analogy where student and knowledge are not enough. You need to teach the student in order to make him to learn something. Now let's summarize. The data is used to teach the model, and that process is called training. And the gradient descent is a part of training, or it is a method of training. So that again gets us into the gradient descent, which is the main focus of this video. Now the gradient descent is used to find the optimal parameters of a model, which is equivalent to training the model on the data. Now what is a parameter? Parameter is the control of the model. It's like the steering wheel of the model. If you choose wrong parameters for your model, you're going to get inaccurate predictions from your model. On the other hand, if you choose optimal parameters or good parameters for your model, you're going to get accurate predictions. So optimal parameters will give you a model which will fit the data perfectly and give you accurate predictions. So the gradient descent starts with random parameters because initially we don't know what are the optimal parameters. That is the goal of the gradient descent. So initially the model with random parameter is made to predict on the data. Now of course, since the model knows nothing about our data, it will make inaccurate predictions. Now we need something to measure these inaccurate predictions in order to make them accurate, or in order to train our model on the data. That is done by cost function represented by j. In this graph, j is the cost function and theta is the parameter. This graph shows the relation between them. Now, for inoptimal parameters or bad parameters, the cost function has very high value. On the other hand, for optimal parameter, the cost function has minimum value. So the whole goal of machine learning or gradient descent boils down to finding the parameter for which the cost function has minimum value. And that is done by the gradient descent, which descends the curve. Now we take small baby steps along the curve in order to reach the minimum of the cost function. You can compare this to an analogy where if you want to descend from the top of a hill in the fastest way possible, you will choose the side which has steepest descent. In the same way, we choose the direction for descending the curve of the cost function in which its value decreases most rapidly. That is the whole idea behind gradient descent. Now, using this approach and repeating this approach, you'll find the optimal parameter. Now, once you fit these optimal parameters into your model, you're going to get a model which fits the data perfectly, and it is ready to make accurate predictions.